the new dopamine hypothesis proposed by House and Kapoor features four distinct components. Firstly, that dopamine dysregulation occurs when multiple hits interact with one another. Second, that the locus of dopamine dysregulation moves from being primarily at the D2 receptor level more towards the presynaptic dopaminergic control level. Third, dopamine dysregulation is linked to psychosis rather than schizophrenia, and schizophrenia may be considered at the extreme end of the psychosis spectrum. Thus was born the concept of psychosis proneness, and the number of hits results in the development of multiple heterogeneous subtypes of schizophrenia. And finally, dopamine dysregulation is thought to alter the appraisal of stimuli, possibly through an aberrant salience process where inappropriate significance is placed on neutral events. Thus, other networks such as the salience network of the brain possibly are involved. Let's start off with a brief history of antipsychotic medications and their development. Antipsychotics were initially called neuroleptic drugs, and these were serendipitously discovered as most medications in medicine. In the early 1950s, chlorpromazine was given to mentally ill patients post-surgically as an antihistamine. What they found was that psychotic symptoms alleviated in these patients. So pharmaceutical companies then made a range of phenothiazine-based antipsychotic preparations. Unfortunately, they also led to a number of side effects such as akathisia, dystonia, dyskinesia, and Parkinsonian side effects. This, however, led to the theory that schizophrenia is possibly related to increased dopamine activity in the brain. So with regards to antipsychotic development, the first generation antipsychotics predominantly focused on dopamine antagonism, but then to maximize tolerability, they had to recruit other mechanisms to ensure that dopamine release was still present or dopamine function was still present in the other areas to minimize side effects such as akathisia and other extrapyramidal side effects, including Parkinsonian side effects. So let's look at how the dopamine theory evolved. There were three key theories that have been developed since the 1960s. The first one was the dopamine receptor hypothesis. And this particular hypothesis came about because individuals that used amphetamine developed psychosis. And amphetamine increases levels of dopamine, and therefore the theory was increased dopamine acted on postsynaptic receptors, thus exacerbating psychosis or triggering off psychosis in vulnerable individuals. So this was the postsynaptic dopamine receptor hypothesis. And this theory, of course, was solidified because by blocking dopamine, D2 antagonists, psychotic symptoms were reduced. However, it only explained the positive symptomatology, and therefore the theory was one-dimensional. It did not include any of the neurodevelopmental deficits that we know are a core part of schizophrenia. Hence, the modified dopamine hypothesis was developed. The modified dopamine hypothesis moved away from this one-dimensional approach and looked at different parts of the dopamine pathways. The modified dopamine hypothesis postulated a prefrontal hypodopaminergic state combined with a subcortical hyperdopaminergic state. So the hyperdopaminergic state resulting in positive symptoms, the prefrontal hypodopaminergic state resulting in a number of cognitive symptoms. However, clearly, this particular theory didn't explain all the symptoms of schizophrenia either, because there were a number of individuals with residual positive or negative symptoms present. Thus, the new dopamine hypothesis proposed by House and Kapoor features four distinct components. Firstly, that dopamine dysregulation occurs when multiple hits interact with one another. Second, that the locus of dopamine dysregulation moves from being primarily at the D2 receptor level more towards the presynaptic dopaminergic control level. Third, dopamine dysregulation is linked to psychosis rather than schizophrenia, and schizophrenia may be considered at the extreme end of the psychosis spectrum. Thus was born the concept of psychosis proneness, and the number of hits results in the development of multiple heterogeneous subtypes of schizophrenia. And finally, dopamine dysregulation is thought to alter the appraisal of stimuli, possibly through an aberrant salience process where inappropriate significance is placed on neutral events. Thus, other networks such as the salience network of the brain possibly are involved. More recently, we also have to take into account the glutamatergic hypothesis. The glutamatergic hypothesis postulates that a hypofunctioning glutamate receptor results in excessive mesolimbic dopamine contributing to positive symptoms. On the other hand, a hypofunctioning glutamate receptor in the prefrontal cortex is also responsible for negative symptoms and cognitive symptoms. We know that one of the key glutamate receptors is the NMDA receptor, and interestingly, the anti-NMDA encephalitis can present with psychotic symptoms and as a differential diagnosis in individuals with psychosis. So let's now look at the two generations of antipsychotics. So broadly, antipsychotic medications are divided into the first generation antipsychotics, the second generation antipsychotics, and the third generation, which are known as the partial agonists. The first generation antipsychotics predominantly are dopamine antagonists. So they block the D2 receptor. In order to understand how antipsychotics work, and what we're trying to do as clinicians in treating psychosis or schizophrenia, we've got to deconstruct schizophrenia as an entity. In order to do this, we have to understand the different pathways in the brain. So firstly, we have the mesolimbic pathway. The mesolimbic pathway begins from the ventral tegmental area where the dopamine neurons originate and project to the nucleus accumbens. This mesolimbic pathway mediates positive symptoms when there is hyperdopaminergia, but this pathway is also the reward pathway. Second, the neurons that originate from the ventral tegmental area also project to the frontal cortex. And here we have two different parts. We have the ventromedial prefrontal cortex and we have the dorsolateral prefrontal cortex. The neurons from the ventral tegmental area where the dopamine neurons are, the ones that project to the ventromedial prefrontal cortex are responsible for mood. Hence why it's important that we evaluate mood in the overall assessment of psychosis. Next, they also project to the dorsolateral prefrontal cortex, which we know is the seat of executive function. This part or this network is responsible for mediating cognitive symptoms and negative symptoms. Note that these parts of the frontal cortex are also linked to the striatum, basal ganglia, the movement areas. Next, we have the other part of the brain where the dopamine neurons are situated, which is the substantia nigra. Projections from the substantia nigra, they go to the basal ganglia, the striatum. This pathway is known as the nigrostriatal pathway. This pathway mediates movements. Then we have the tubero-infundibular pathway, which connects the pituitary to the hypothalamus. Specifically here, we've got to think about prolactin. The prolactin releasing area in the pituitary has dopamine receptors. There is an inverse relationship between dopamine and prolactin, which means if there is low dopamine, there's increased prolactin and vice versa. And finally, we've got to think about metabolic syndrome. And the reason we think about metabolic syndrome, of course, some of the aspects occur in the periphery, but there are key elements that occur in the brain that mediate appetite, that mediate adiposity, that we need to take into account overall in the treatment of schizophrenia. So to summarize, what we've got now is the mesolimbic system mediating positive symptoms. It's also the reward pathway. We have the mesocortical pathways too, projecting into the mood area, the ventromedial prefrontal cortex, and the dorsolateral prefrontal cortex mediating negative symptoms and cognition. Then we have the nigrostriatal area mediating movements, the tubero-infundibular pathway mediating prolactin, and finally, metabolic syndrome. Now, as a psychopharmacologist in treatment, what I've got to consider is I want to reduce, in the context of positive symptoms, I want to reduce excessive mesolimbic dopamine activity. Therefore, I want to introduce a medication that reduces this dopamine activity. And that's where I can introduce an antipsychotic that blocks dopamine receptors, a D2 antagonist. However, at the same time, I want to ensure there isn't excessive dopamine blockade in this mesolimbic pathway, because if I block dopamine excessively in this pathway, the individual will not experience reward. And this is where individuals with schizophrenia may consider self-medication through smoking, because smoking can increase dopamine in this particular pathway. They may consider substance use to self-medicate to experience reward. Therefore, an optimum balance of dopamine modulation is required in the management of positive symptoms. On the other hand, whilst blocking dopamine in the mesolimbic pathway, I need to ensure that dopamine release in the mesocortical pathway, tuberoinfundibular pathway, and the nigrostriatal pathway is not blocked excessively, because if I do that, individuals will present with extrapyramidal side effects, so akathisia, Parkinsonian side effects, dystonia, for example. They will present with secondary depression because frontal dopamine has dropped down. They will present with secondary negative symptoms, and they will present with secondary cognitive symptoms. These secondary cognitive symptoms include deficits with planning, sequencing, detecting errors, motivation, initiation of tasks, and terminating tasks.